Alright, so today we're going to do vertical and horizontal shifts of our sine and cosine functions. A really quick refresher from Algebra 2 is y'all did parent functions in Algebra 2. So this is how you transformed, I'm just going to show you the quadratic parent function. And you said A, the thing that's going to get multiplied, is going to stretch it. So that's kind of like our amplitude that we did yesterday. It gets multiplied, it stretches it. H, when it's inside with the X. X is a left and right movement. H is a left and right movement. And actually when it's minus, it's right, and when it's plus, it's left. And then K, what's all by itself, is going to affect the Y by going up and down. So kind of, if you keep that in mind, it might help because it's really the same for sine and cosine, except it's with a trig function. So let's do some sine and cosine. So yesterday we did sine and cosine. If you remember from yesterday, sine, if we consider in degrees, let's just say in degrees. So a period takes 360 degrees, and sine is the one that we said it looks like an S. So it kind of goes like that. Okay, and then cosine is still 360 degrees for one period, but cosine is that U shape. So now it starts at the top and it has that U shape. Alright, so keep that in mind. So if we consider the parent functions, y equals sine theta. So y equals 5 plus sine theta. So what we're doing now is we're taking the sine theta function and we're transforming it just with one transformation. So in A, all we're doing is doing 5 plus. So if you notice that 5 is a positive 5 and it's outside of the parentheses. So that's going to take sine theta and just move it up 5 because you're taking that function, and after you get that function, that y value is going to be 5 higher. So if this is my parent function, it would look like this. Remember that this would be 1 and negative 1. Well, now if this is the 1 and this is the negative 1, I'm going to go 5 higher than that. So 5 higher is going to mean, well, instead of this being my sinusoidal axis, it's going to be at, let me change colors, 5. Let me move this over to the side. Alright, so this is our parent function, where this is 1 and this is negative 1. This is my sinusoidal axis here. Well, you're just going to take this whole thing and move it up 5. So now the sinusoidal axis is going to be at 5, and if you go 1 higher than that, then that's 6, and 1 lower than that is 4. So now my parent function is still going to have that general S shape, but that general S shape is going to be 5 higher than it was. So that is y equals 5 plus sine theta. Okay, alright, let's do B. So B reads y equals negative 3 plus sine theta. So once again, it's negative 3 is on the outside of the parentheses, so it's going to take sine theta and move it down 3. So I'll do the same thing. This is to 360, and I'm just kind of trying to draw, this is my parent function. So I'm going to take the sinusoidal axis and I'm going to move it down 3. So now here at negative 3, I will have an amplitude of 1, so I'll go up to negative 2 and down to negative 4. This is my sinusoidal axis, and my function is still going to have that S shape, but now it's down 3. So this is y equals -3 plus sine theta. All right, the next one, y equals sine, and then open parentheses, theta plus 50. So now that your parentheses, your theta is part of a parentheses with another number, this 50 is going to move it in the same direction as theta, and theta is on the x-axis. So we're going to take that x-axis and move it, when you see a plus sign, it's actually left. So we're going to move it left 50. I'm going to come over here again. So typically this is to 360. So my sine function normally looks like this. Well, if I take this whole thing and I move it left 50, well, normally I start at 0, so when I move it left, I'm going to have to come over here to the negative. This is going to be -50, and if the period is still 360, then I'm going to be 50 less than that, so that's going to be 310. So now I'm starting at the -50, and I'm going to come around this way. So this green represents 50 moved over to the left. Alright, so let's do one more. I'm going to pause this and delete all this. Here we go, it's a lot better. Okay, so y equals sine theta minus 3 pi over 4. So now you can kind of assume that you're in radians because this is a radian. This should really say x. Let me go ahead and change that. We're trying to use x for radians and theta for degrees, so this should say x. So x minus 3 pi over 4. So now this minus sign is going to tell us to go right 3 pi over 4. Alright, so in radians, this is a little bit harder in radians, but it's still doable. So this is 0, and we would end our period at 2 pi. So our parent function, if you want to do all those tick marks in between, we're still going to do that. I'm just kind of, this is just the introduction. So this would be my parent function. So we're going to take that parent function and move it to the right 3 pi over 4. Well, remember that this is 2 pi, so this is pi over 2, pi, 3 pi over 2, and 2 pi. 3 pi over 4 is in between, that's like 3/4, so that's in between half and full. So this is 3 pi over 4. So then 3 pi over 4 is how this has been moved over to the right. I'm still going to mark every half, so this is 5 pi over 4, 7 pi over 4, 9 pi over 4, and 11 pi over 4. So I'm going to start at the 0, and I go up, middle, down, middle. So this represents moving to the right 3 pi over 4. Okay. All right. So compare and contrast the graphs of y equals sine theta and y equals negative sine theta. So now what's different is the negative sign. So sine theta looks like this, and when we have a negative sign, that makes it reflect over the x-axis. That was another transformation that you did in Algebra 2. So I'll do this in red. So if we reflect over the x-axis, now that's going to look like this. Okay, and then so cosine theta, same idea. So I'll draw the parent function first, and then if I reflect it over the x-axis, then I'm going to start down, and then I'll make that u, but it's an upside down u. Alright, so in general, this is our what trig functions look like. So the letters are going to stay consistent. K is the thing that's going to be all by itself, and that's responsible for going up and down. So up if it's a positive, and down if it's a negative. A, what gets multiplied times the trig, is your amplitude. B is how your period changes. So I'm going to say that's the change in the period. It is not the period, but it is the change in the period. This is what we talked about yesterday. So in degrees, we take 360 and divide it by B, or in radians, we take 2 pi and divide it by B. And then H is how you move right and left. So I'll say left first because left is actually when it's positive, and then right is when it's negative. Alright, so let's do some examples. So we've created this little box for y'all just to kind of help. So use this box, it is extremely helpful, and just kind of fill out the box, and then after you fill out the box you can start to graph it. So the box kind of steps you through everything. First it says, well, what is your trig? So your trig is cosine, because that's the trig that's in the problem. Your vertical shift. Vertical shift is this number that's all by itself. So that's 4 in this case, and since it is a positive 4, we're going to go up 4. Our horizontal shift, we're in degrees, is 30 degrees, and when you see a minus sign, it's actually to the right. We will not reflect because your trig is positive. So no, we will not reflect, which means cosine, this is going to be what our cosine function looks like. It's the positive shape u. So we're going to start up at the top. I'm just going to draw what the starting place looks like. And our amplitude is the number in front of the trig, which you don't see one, so you can go ahead and assume that's the 1, like the parent function is. The period is the number in between the trig and the theta, which again, we don't see one. So typically we say it's 360, and you can divide it by 1 if you want, but that's still going to be 360. And so we find those critical points by doing 360 divided by 4, which is 90, which is just like our when we studied the parent function is. Alright, so make sure you get this box down, and let's go ahead and draw our XY axis. Keep in mind you need to go up 4 and right 30. So if you're going to go up 4, I need to see more up, and I need to see all the way to the right. I don't need to see anything to the left. If you went left, you'd want to see stuff over here, but we don't need to see the left as much. Okay, so since we go up 4, typically our sinusoidal axis is on the x-axis, but when you go up 4, now your sinusoidal axis is up 4. So put a 4, and I like to draw the sinusoidal axis. I think it's extremely helpful. Now if you wanted to go ahead, we could do our horizontal shift now. So we're going to start 30 to the right, and we make 1, 2, 3, 4. So this is the end of our first cycle. 1, 2, 3, 4. This would be the end of our second cycle. And each of these tick marks is separated by the critical point of 90. So 30 plus 90 is 120, plus 90 is 210, plus 90 is 300, plus 90 is 390. So that kind of makes sense, because if you started with 30 and your period is 360, then you should end at 390. Let's keep going. Plus 90 is 480, is 570, is 660, and 750 is how we'll end. Okay, we're not reflecting. We're going to start like this. Our amplitude is 1, so let's go ahead and finish the y-axis. So that means that this is 5, and this is 3. And that's everything on my box. So now I just need to start to draw it. So remember that we're going to do the U shape, and you start here at the 30. So at the 30, I'm going to start at the top, because that's the U cosine shape. So at the 30, I'm going to start at the top. And then from the top, I go top, middle, down, middle, top. So that's one cycle. Now I need to start again. So if I start here, I'm still starting at the top, I'm going to make a U. So top, middle, down. I don't know why I did that so far down. Down, middle, top. Okay, so this is one cycle, and this is my second cycle. And that is our first transformed trig. Alright, let's go on. So now let's practice some radians. So y equals -6 plus sine open x plus pi over 2. So now my trig is sine. So trig is sine. My vertical shift is this number in the front, so that's -6, so that tells me to go down 6. My horizontal shift, horizontal is what's with the parentheses, so this case it's plus, which tells me left, pi over 2, notice we're in radians. My sign is positive, so I will not be reflecting, which means I have that general S shape. And my amplitude is 1 again. Amplitude is the number in front of a trig, which I don't have, so that's 1. And then the period is here, supposed to be here, which is also 1. So we're going to be 2 pi in radians divided by 1, which is 2 pi. And to find the critical points, I divide that by 4. 2 pi over 4, which is pi over 2. Okay. Alright, so go ahead and make your XY axis. Careful here though, because you do need to go left, and we also need to go down. So, I mean, you need to draw an XY axis that accommodates you going left and down. So if you need to go left, then make sure you leave some space for you to go left. And if you need to go down, you need to see primarily the down stuff. And I went left a little bit. And if you mess up, I mean, maybe I think I should have left a little bit more room. I mean, you can just erase this and start over. So let's say I wanted to go a little bit more left and a little bit more down. So just kind of make it work. Alright, so I'm going to start with, it doesn't matter how you start. Let's start with the vertical shift. So typically the sinusoidal axis is on your x-axis. We're going to take that and move it down 6. So down is negative. And this is my sinusoidal axis now. Okay, I'm going to move, typically I'm starting at 0, but I want to move it left pi over 2. So when you move it left pi over 2, that's negative pi over 2. And now I'm going to go ahead and mark all of my critical points. So I have, okay, you might want to think before you just start marking this. If you're going to move critical points by pi over 2, if you're starting at negative pi over 2, when you add pi over 2, you're actually going to land right here on the 0. So make sure you mark that 0. So that's the first critical point. So that's critical point 1, 2, 3, 4. This is the first phase or first cycle. 1, 2, 3, 4. I'm kind of squishing that in here. So when I add pi over 2, like I said, this is 0. Then pi over 2 plus pi over 2 is 2 pi over 2. If you want to say that that's pi, you can do that. 3 pi over 2, 4 pi over 2. I'm just adding pi over 2. 5 pi over 2. 6 pi over 2. And 7 pi over 2. Okay, what else do I need to do? I haven't done my amplitude yet, so I start down 6, I'm going to go up 1 from that and down 1 from that. So that's going to end me at negative 5 and negative 7. And it looks like I'm ready to start. So sine starts in the middle, then it goes up, middle, down, middle. So it starts in the middle, then I'm going to go up. Remember to land on the y-axis in this case. Middle, down, middle. Up, middle, down, middle. Alright, so let's do that. I start in the middle, then we go up, middle, down, middle. Up, middle, down, middle, and we connect. There we have it. Alright. Let's do another one. So negative 7 minus cosine theta minus 200. We are in degrees here. So start off by looking at what kind of trig you have. So this is a cosine, so go ahead and fill in your graph or your box. This is cosine. Okay, my vertical shift is the negative 7, so that's going to be down 7. My horizontal shift is right here, so that's right 200. My reflection, this is the first case. I do actually reflect because cosine is negative, so yes, I do. So cosine that's typically this is going to get reflected, so I'm going to be like this now. My amplitude is still 1. Amplitude is just the number. You don't need to say it's negative. The fact that it's negative told you you reflect. Amplitude is just the number here, which is 1. My period, again, there's not a change in period. Tomorrow we're going to practice putting everything together, so we'll be changing the period and amplitude tomorrow. So that's still 360, and the critical points is 360 divided by 4, which is 90. Alright, so we need to make an XY axis that allows us to go down 7 and right 200. So if you move right, that's not going to affect, we can make that really close to the edge. And then down 7, so I do need to see a lot of the down, so I'm going to make this way up here. So if I'm going to go down 7, now my sinusoidal axis is way down here at negative 7. And let's go ahead and start with my x-axis now. So this is right 200. and I'm going to label my critical point. So this is 1, 2, 3, 4. This is the end of my first cycle. 1, 2, 3, 4. This is the end of my second cycle. Add 90, so that's 290, 380, 470, 560. Add 90 is 650. Sorry. Oh my gosh, I don't want to erase all of that. Okay, I'm just going to tie right over that. 650, 740, 830, and 920. And my amplitude, I need to go up 1 and down 1. And I'm ready to start. So cosine usually starts at the top, but because I reflected, now I'm going to start at the bottom. So when I start at the bottom, I'm going to start at -8, and then I go middle, top, middle, bottom, middle, top, middle, bottom. That's it. Alright, last one. Y equals 5 plus pi over 3 x in radians. So this is quite a bit different. So we're going to do cosine here. Our vertical shift is the number all by itself. So that's a +5, so that tells us up 5. Horizontal shift is the number inside of the parentheses. So look closely. The number inside of the parentheses, there's actually not anything here. So this is going back to having no horizontal shift. So we'd start at the 0. My cosine is positive, so I will not reflect, which means I'm going to do that typical U shape. My amplitude, the number is still 1 in front of that. But what has changed is my period, because now what's being multiplied times the x. If you're getting confused why this is not changing the horizontal shift, I'm going to zoom out. The horizontal shift is inside being added or subtracted. Whoa. Being added or subtracted to the parenthesis. The period, if I can just write all of this out, y equals k plus a times some trig, whatever it is, and then there's the b theta minus h. So what affects the period is the thing that's being in between the trig and the theta. It gets multiplied times the theta, or in this case, the x, because we're in radians. But the key thing is that it's getting multiplied, not added or subtracted. That's horizontal shifts. But being multiplied affects the period. So we have to figure out the period. This is what we were practicing yesterday by doing, well, the typical period in radians is 2 pi. And you're going to divide it by that number that you see, which is pi over 3. So divided by pi over 3. So if you want to do this division, you're going to have to do 3 over pi, the reciprocal, on top and bottom to get that magic number of 1. So really all it does here is just make this go away. If you notice, you have a pi left on top, and you're going to have a pi on bottom. That's going to go away, and 2 times 3 is 6. So in radians, the period is going to be just 6. It's not always a pi. Don't always think that there's going to have to be a pi. Sometimes it'll cancel out. And then the critical points are going to be take that 6 and divide it by 4. And so you get 3 over 2. If you prefer to use 1.5, there's nothing wrong with that. I'm going to use 3 over 2. Alright, so make sure you get that box down. Okay, so I need to make an XY axis that accommodates me going up 5, but no horizontally. So I'm going to need to go a lot up, but not any really horizontally. Which means I'm going to start at the 0. Okay, I'm going to have 1, 2, 3, 4. This is the end of my first cycle. 1, 2, 3, 4. This is the end of my second cycle. This is my starting place is 0 because I'm not doing a horizontal shift, so I am starting here, and I'm going to add 3 over 2. If you want to be adding 1.5, that's fine. 3 over 2 plus 3 over 2 is 6 over 2. Plus 3 over 2 is 9 over 2, is 12 over 2, 15 over 2, 18 over 2, 21 over 2, and 24 over 2. I have a vertical shift up 5, and an amplitude of 1. This was my cosine not reflected. So if I'm not reflected for cosine, I start at the top, and then I go middle, down, middle, top, middle, down, middle, top. Okay. Alright, this is kind of combining what we did yesterday and today. This is a lot of what we're going to be working on tomorrow, is combining both of them. And what I mean by that is the period. This was what we did yesterday, the period stuff. Alright, that's it for today.